Hello everyone, today I will be talking about the Rydberg formula and atomic emission. Here we see a diagram of atomic absorption. Each ring that you see around the nucleus of the atom is an energy level which can be represented by the principal quantum number n. So what happens here is the electron absorbs some type of electromagnetic energy and it jumps up from its ground state, which is n1, to the excited state, n3. Now here's an example of atomic emission. Once an atom goes through the process of atomic absorption, it then goes into the process of atomic emission. Atomic emission happens when an electron in the excited state falls back down to its ground state, releasing a photon, which can be represented by the Greek alphabet gamma. One thing I wanted to add to this is Coulomb's law. The reason why I wanted to explain Coulomb's law is it explains the forces of attraction and repulsion. So right here we have the force of attraction. Forces of attraction have a negative electrostatic force. The reason for this is because the distance is a positive, the constant, Coulomb's constant, is a positive, and then here we have the proton and the electron, so the attraction between the proton and the electron. For the electrostatic force of attraction, the more negative the value of F, the stronger the attractive forces are. On the other hand, the electrostatic force of repulsion is a positive. This is because the K value is a positive, the constant's a positive, and so is the distance. And here we have two negative charges, and the negative charges cancel each other out and they turn into a positive. Down here we see the same thing with the constant and the distance, but now we have two positive charges. So they both repel each other, they're both protons that repel each other, and they create a positive electrostatic repulsion. Now that we understand all this, we can now apply it to the atomic emission. As we can see here, as the R value decreases, the force of attraction increases. Before I get started on teaching the Rydberg equation, I wanted to say that there's different forms of this equation, and this is the one we will be using. Along with different equations, there are also different constants, so this is the one we will be using. Before we move on to an example question, let's try to define the rest of the variables. So this variable right here is the atomic number of the atom that's either absorbing or emitting the photon. This variable right here is the final energy level that the electron will be on, while this one is the starting point or the initial energy level that the electron will be on. Now for this example question, let's calculate the energy of the photon that's being emitted. So because this is a hydrogen atom, we know that the atomic number is number 1. So we could just cross that out because it's just going to multiply the rest by 1. Now we've taken care of that one variable, let's take care of these two. Now the final energy level that the electron will be on is N1. And the initial energy level that the electron will be on is N3. We already know what R is, that's just the Rydberg's constant. Once we plug all that into a calculator, we should get negative 1.936 times 10 to the negative 18th. The reason why this is a negative value is because the electron is releasing the energy. Now to finish the calculation to find the energy of a photon, all we have to do is to take the absolute value of the change of energy of the electron. So the energy of the photon comes out to be 1.936 times 10 to the negative 18th joules. Thank you everyone for watching my video, and I hope you enjoyed.